I'm going to start by introducing this week's speaker, Jesse Dunietz. Jesse got his PhD at CMU in the computer science department, but he was advised by two LTI people, Jaime Carbonell and me. Jesse was very easy to advise because he is a professional science communicator, which means that he writes about science for the public, and he also trains scientists to communicate to the public. And so it was always fun having meetings with him because he was very good at communicating what he was doing. And also that his work was really fascinating from the perspective of AI and computational linguistics. So Jesse is now at Elemental Cognition, which I guess I think of as a think tank that was started by Dave Ferrucci of IBM Watson. And at Elemental Cognition, they are not just trying to lead on leaderboards, but are trying to really think deeply about what AI is and NLP. And that's related to what Jesse is going to talk to us about today. So Jesse, thank you for joining us, and please go ahead.
Great, thanks for the introduction, Laurie. In terms of logistics, I don't want to make you all hold all questions to the very end. So feel free to use the Zoom raise hand functionality. If you have immediate clarification questions, short clarification questions, I'll try to watch that in Zoom, and I'll also take some questions at the ends of sections. And with that, I want to talk today about reading comprehension. So this is a term that gets thrown about a fair amount in NLP these days. Usually when people talk about machine reading comprehension, or MRC, they're usually referring to this pretty standard setup where we have a passage or maybe some collection of passages, a bunch of questions about those passages. We feed the passages and the questions to a machine, a model. The model is supposed to output some answers to those questions, and the model is scored on how well it can answer them. And in much the same way that a syntactic tree bank is supposed to measure the ability of a system to parse out the constituent structures of language, a data set for machine reading comprehension is supposed to be able to measure the ability of that model, that system, to comprehend the passages that it was fed. Now, this is an increasingly popular paradigm in NLP. Here is a hopefully comprehensive chart of MRC data sets based on a couple of survey papers referenced at the bottom there. I'm sure I've missed one or two, but I don't really want to talk about the details here. The point is just that there are a lot of these data sets. And this is, by the way, just counting data sets that follow that read a passage, answer some questions setup that I described a few moments ago. So we're not counting here conversational setups where the system is supposed to interact with the questioner to elicit more information, or multimodal settings where you're getting a passage and an image or something like that. Just the read a passage, answer questions, it's really exploded, particularly over the past few years. And you sometimes hear people talk about these, at least some of these data sets, as being solved, or even maybe they'll talk about reducing some other task to machine reading comprehension, as if that's something that we now know how to do. And the starting point for this talk is a certain dissatisfaction with talking about doing well on these data sets as being synonymous with solving machine reading comprehension. What I mean by that is, let's imagine that systems just keep getting better and better at these data sets and matching or even maybe exceeding human performance on these data sets. Would we then be really comfortable saying that reading comprehension is quote unquote solved? I mean, what if somebody told you, yes, here is a machine that comprehends what it reads. Now think of all the things that you would expect of that machine, right? You'd expect it to be able to do things like answer questions about a clinical timeline, what happened to this patient, what do we make of it, assess compliance of some proposal or some system with regulations or legal obligations, maybe read a description of a game world and adjust a character's responses based on how this world is supposed to work, maybe read a human's directions and then guide a robot to find some requested item based on the information that was in those directions. So things that the machine should be able to do with the information that it supposedly drew out of the text that it read. And the question that I'm posing is, would we really trust the techniques that win those leaderboards to be capable of stuff like this? My intuition is no, and I suspect that most of you would probably agree with that. So what I want to do for the rest of today is first share our thinking about what makes current tests of reading comprehension not fully satisfying, then offer some ideas about what might make them more satisfying, particularly this idea that we call the template of understanding, or ToU. Then I'll discuss how we've worked to operationalize that high-level idea of the ToU into more concrete data sets and evaluations. Particularly, I'll focus on some of the annotation challenges there and how we've tried to address them. I'll then discuss some experiments so far, mostly still small or incomplete experiments, but working towards building data sets and assessing current systems on how they can perform on them. And finally, I'll wrap up with a few thoughts about where we're looking to go next. Now, I've said we a couple times in the past minute. The we that I'm talking about is my colleagues and myself at Elemental Cognition, company that, as Laurie said, is where I work. I especially want to call out Dave Ferrucci, our CEO, as the originator of a lot of the ideas I'll be talking about. To set expectations here, most of this is going to be on the annotation and evaluation side, so you can take off your modeling hats and put on your data set development hats. And also some of this is ongoing work, very much still a work in progress, but hopefully it will still be thought-provoking and interesting, and we certainly welcome any thoughts that you all have on how this research agenda can proceed or should proceed. One more quick bit of expectation setting. I'm not really going to be discussing what data or modeling would help systems improve at machine reading comprehension. There's lots of other good work on that, other people asking good questions and thinking deeply about that. I want to focus specifically on the question of evaluation, making evaluation more rigorous. So what should a machine reading comprehension system know once it has read a text that we should ask it questions about to evaluate it? And this is largely based on an ACL 2020 paper that we wrote with some updates since that point. So with all that in mind, let's talk about what's perhaps missing from the existing paradigms for evaluating reading comprehension. We posit that the core problem boils down to not following the most unambiguous, clear-cut approach for testing comprehension. What would that approach be? Given some selected passages, first, before creating the test questions, determine what content you care about the machine's understanding from the passages. And by content, what I'm talking about is the information expressed, implied, or relied on by the passage. So what should a system come away with? What information should a system come away with having read that text? And then we can design tests that thoroughly probe for comprehension of that content to assess reading comprehension. Of course, what content matters in this step depends on what you're using the system for. So really, you need to start before any of this by establishing what use cases you imagine the systems that you're working towards actually helping with. Okay, maybe this sequence seems totally banal and obvious, but the reality is that this is very much not the norm in the field. So let's look at some of the alternative ways that reading comprehension data sets are gathered and how those generally result in less compelling evaluations of reading comprehension. The number one strategy for developing these data sets is have humans look at the passages that you want to ask questions on, read the passages, write down some questions. Straightforward, very popular. Problem is, as is well known, humans tend to ask questions that can be answered with very simple lexical cues when you do this. Often, for example, if you just ask Turkers to ask some questions, they'll start drawing on phrases from the passage and incorporate those into the question and the answers. So you start to get reports of experiments showing that systems can get 50 or 70% on some of these data sets without even looking at the question or without even looking at the passage. So that's clearly problematic. It suggests that we're setting up the tasks so that the systems can too easily cheat. To prevent that kind of cheating, the typical twist that people put on this approach is adding various hoops that the systems have to jump through to make the questions trickier. This can be things like numerical reasoning or multi-hop reasoning, where you have a couple of facts in the passage that you have to combine and reason about in some way to get to the answer. Sometimes people look at incorporating common sense knowledge into the questions, or filtering even with adversarial baselines, throwing out questions that are too easily answered by today's systems. And indeed, these kinds of approaches make the evaluation data sets harder for today's NLP systems to achieve good scores on. However, the point of evaluations is not really just to be hard. The point ultimately, at least if we're thinking about it as an evaluation, is to assess progress towards some goal. So designing data sets primarily to be hard is a bit like training to become a professional sprinter by walking into the gym, looking around, and doing any exercises that look tough. You might get some good exercise out of it, you might strengthen some muscles, but it's just too haphazard to achieve the goal that you're really working towards. And for reading comprehension, the goal is to understand the content that applications ultimately need, not to answer arbitrary hard questions. So that's a major concern we have about the first approach here, these manually written questions. Second major method for gathering data sets is to use naturally occurring questions. That can be things like information from forums, or questions asked on forums rather, perhaps search queries. And this seems very natural because you know it's questions people actually have. The big issue is that people tend to not ask questions about things that are obvious to humans. And in fact, if you think about what information you really want a system, an automated system, to get out of a passage that it reads, often the things that you trust at least to actually come away with are the things that are obvious to humans, right? So often our NLP systems fall on their faces on things that we humans look and go, oh my God, that was so obvious, but it's not obvious to the machine. So we need to make sure we're covering those in our evaluations. And there's also some of this issue of omitting obvious questions in the manually written questions as well. A second major issue is that these data sets start from questions in the case of multiple choice, at least with associated answers, and they search for documents that probably contain the answers. So what that means is that the questions actually only cover a very small fraction of the content of any given document. You find you have a question that you know is answered by this one line out of 500 and ignore everything else in that document. So if systems do manage to do a good job of extracting those couple of answers, yeah, we can have some confidence that they can locate and extract answers to questions people have. That's valuable and important. But it's a stretch then to say that they've comprehended the documents, particularly if the comprehension-based behaviors you're ultimately going to want out of systems is more complex than what amounts to an information retrieval task. Third common approach is to pull questions from tests designed for humans. Sometimes this is trivia questions. Sometimes this is questions, for example, for English language learners. Again, the problems here are that humans aren't tested on things that humans find obvious, and that typically the passages are found retrospectively, starting with a trivia question and going back to say, where might I find an answer to this question, not looking at trying to understand that whole document. A final approach that people sometimes use is algorithmic generation. This could be like the CNN Daily Mail data set, masking out entities in documents directly. Sometimes this also, these data sets are created by somehow generating language from knowledge bases, or even in the case of some of the baby data sets, generated from simple simulations, and in some kind of simple, straightforward way, translating a simulated scenario into questions that can be asked about that scenario. Now, this actually, we think is more promising in the sense that the algorithm that you use to generate questions implicitly, maybe even explicitly, encodes what content you care about the machine knowing. In practice, though, typically these approaches are actually used to design multi-hop reasoning data sets or other kinds of hard reasoning. So again, that's a problematic focus on difficulty. From the perspective of a downstream application, we don't really care whether a given thing that we wanted to get out of reading this passage required 0 hops of inference or 7 hops of inference, as long as we got it. So with some possible exceptions that we can discuss in the Q&A if people are interested, almost all the existing data sets suffer from some combination of these problems. And the last 3 problems here in particular, the last 3 columns, are specifically arising because the data sets are not generated using that content-first approach that I discussed earlier. There's also an intersecting issue that affects the ability of these data sets to evaluate reading comprehension, and that's the issue of format. There are 3 basic formats that tend to be used for reading comprehension data sets. Probably one of the most popular ones is span selection. That was, I think, popularized by Squad and has been used by many other data sets as well. There's also multiple choice. I'm throwing Boolean yes/no questions into that bucket as well. And I actually only know of one example of free-form question answering data set where the system is given a passage and a question and is just expected to generate text, arbitrary text, as an answer. So these are the paradigms that are considered to be kind of available. From our perspective, the biggest issue here is with the span selection format, which immediately rules out a pretty big swath of the content you might want to test systems on. Anything that is not expressed as a clean, explicit span of text in the original passage, that's a question you can't even ask systems about, because it's just not even possible for them to answer given the answer format they're expected to give. And again, implicit events, implicit entities, things that are kind of vague or fuzzy, these are things that you really might care about quite a lot for an application. Now, everything beyond that is kind of a side theme for us on the format question, but we also are somewhat concerned, again, about this issue of artificial easiness, where because particularly in multiple choice questions where you literally have the choices listed out for you, that gives systems extra hints about what the answers probably are. There's only like 4 or so of them that really are plausible. In a setting where you want to actually comprehend a text, that's often not ultimately the thing that you care about doing. You have much more difficult settings there. Even in span selection, there's a limited set of spans that you're choosing from. Now, at least in the case of multiple choice, you can actually test on a wide variety of arbitrary content. So that's a secondary, this format question is a secondary issue for us. But ultimately, we think probably we want to go to free-form generation and evaluation. So we'll come back to this issue of format a little later. But span selection from our perspective is out. Now, before I move on from the existing data sets, I want to emphasize that we're not saying that difficulty-focused data sets are bad. These are very useful data sets. They are testing behaviors that are often necessary for reading comprehension, things like numerical reasoning, multi-hop reasoning, common sense, world knowledge. All of these things are important often for the kinds of reading comprehension and questions that we would want systems to be able to do, which means that if they can't do them, that's an important source of error that will drag down overall top-line reading comprehension metrics. The danger here is in misinterpreting performance on these kinds of questions as a top-line MRC metric. That would be like saying, well, we want systems to be able to parse syntax, and we know that prepositional attachment is hard, or conjunctions are hard, so we're going to report evaluations on prepositional attachment data sets or conjunctions data sets. That's great, it's useful, but it doesn't tell you how close you are to having a fully functional parser that can really handle just about anything that you throw at it. So unless what you really care about is interpreting Groucho Marx jokes about shooting elephants in pajamas, as the classic example goes, that's really a question of error analysis and mitigation, not a measure of how good the system is at doing the thing you ultimately want it to do. So we see these kinds of data sets as being potentially useful training data and as good for the later step in the process of how are we doing on our ultimate goals and what areas are we failing in, or where do we need to make more progress. But we ultimately want to know how close we are to doing all of these things and anything else needed for applications. All right, So let's move on then to, from that diagnosis of a problem to the proposed direction for a solution that we are suggesting. Naturally, the starting point for us is this content-first approach. By the way, this is exactly how human reading comprehension tests are suggested, at least the ones that are well-designed and pedagogically sound. You start by saying, what do we want children or other readers to be able to do with what they read? And then we design questions and tests that try to distinguish between people who are able to do that and people who are less able to do that. Of course, in the case of computers, we want to be even more rigorous and even more thorough about testing abilities, because we trust children's cognitive abilities in general probably much more than we trust machines' abilities. So we think they will be much more likely to trick us into thinking they can do something when they can't. So this is definitely a reasonable way to approach designing a test. The problem is that every application is different. And so if we want MRC evaluation to be driven by what content the applications are ultimately going to need, we want to find some way of working on reading comprehension in a broad way without completely balkanizing the field by application and having no sense of where the field stands overall. So one possibility for doing that is to find a cluster of similar applications that rely on similar kinds of texts. So we can think of each MRC application as having two key characteristics: the genre of the text that it's working with and what information the applications will need it to extract. And in this visual metaphor, we're kind of thinking of the genre as like the platform that the application is built on top of. So if we can find a cluster where many different applications need to comprehend similar kinds of information from similar kinds of texts, we can characterize those common elements, those shared elements of comprehension, treat them as a somewhat generic, broadly applicable test for reading comprehension. And we call those elements a template of understanding, or ToU. And once we've done the work of defining what goes into that ToU, given a passage that we're trying to test on, we can generate a thorough account of what passage-specific content we should be asking about for someone who's read this particular passage by filling in this template for the passage. Now, any given application might need more or less of the template of understanding. They might decide, it might be for a given application that not all of the ToU is necessary, but doing well on this ToU would mean that you could do a sizable fraction of what's needed for a sizable range of applications. Okay, so now we need to find a genre where this approach would work. The genre that we propose is stories. This is a promising approach for a couple of reasons. One is that understanding what happens in a story is essential for many different applications. That can be anything from extracting information from medical records to processing intelligence reports, to assessing customer feedback, processing financial news, automated legal analysis. Lots of things involve either reading background information on stories that you want to extract information or knowledge from, or taking input from a user about some story that's the person you're ultimately going to be helping, and they want to tell you what's going on with them that they need help with. This is not surprising that stories are so pervasive in applications, given that social science also suggests that stories are central to the way that humans think about the world, central to the way we communicate about the world. So they're kind of just everywhere in our thought and our communication. In addition to that, we have a decent idea of what content will matter coming from the cognitive science literature, which suggests that when human readers read a story for some downstream purpose that they want to understand the story for, the things that they most attend to are locations of entities and events, locations where events occur and where entities are located, the timeline of events, what happens and when, the causes of events, and the motivations for agents taking actions. So apparently humans need this content, these pieces of content, to do the things that they want to do with what they're reading in stories. So it's at least a reasonable hypothesis that automated systems will need to understand similar content to do the things that we want them to do with stories. And I won't go into it now, but in the ACL paper that I mentioned at the beginning, we provide a little more support for that hypothesis with some more concrete examples in the appendix. So based on that cognitive science research, we propose that for stories, a template of understanding should cover questions on those same 4 categories of content. We have spatial questions that ask where are entities positioned and how are they configured throughout the story, how are they oriented. Temporal questions asking what events and states occur and with what relative and absolute timing. There are causal questions about how different events and states mechanistically, through just the natural order of laws of physics in the universe, lead to other events and states that are described or implied by the text. And finally, motivational questions focusing on agents acting deliberately. How do their beliefs, desires, goals, and emotions lead to them choosing those actions? And we're arguing that a machine should be able to answer all of these questions about all the different entities or events that a story describes or even implies. And if a machine can do that reliably, that's pretty compelling evidence that it has at least some minimum baseline of comprehension. It's built up a trustworthy, reliable model of the stuff described in the story. Now, we are not trying to put ourselves in the position of this classic XKCD, making one reading comprehension standard to rule them all. We don't want to be the people saying, oh no, there's 14 competing standards. Let's make a universal standard. Now there's 15 competing standards. What we're saying is let's come up with a different paradigm for developing standards. We happen to think that this TOU for stories is a pretty good starting point. It's a standard that should be widely applicable to a lot of situations, again, because stories are so important, so intrinsic to so many applications. So they're a nice broad spectrum way to get a sense of system capabilities, but you could imagine applying exactly the same approach to many different genres beyond stories. For example, you could imagine asking, what is the essential pieces of content that you would need a system to extract from biomedical papers for suggesting techniques for a given experimental setup, given the results of previous work, or maybe various other similar kinds of applications based on that genre. Likewise for compliance guideline documents or financial reports, it would probably be a little less general because those are more field specific kinds of information, kinds of genres of text that you'd be looking at. But the important thing here is the approach that could be applied to many, many different places. All right. So now how do we turn this big abstract TOU idea into concrete evaluations? I want to talk about a couple of approaches and ideas that we've pursued at Elemental Cognition. Some parts of this are largely complete, some are works in progress, and some of what I'll be talking about is really unanswered questions. The first and primary approach that I'll discuss to evaluation is what we call records of understanding, or ROUs, not to be confused with rodents of unusual size from Princess Bride. Let me demonstrate this with an example, sample story fragment here. One day it was raining when Allie arrived. This is to walk the dog. Rover ran out the door. He barked when he felt the rain. He ran right back inside. Okay. Given this story, or the fragment and the rest of the story that goes along with it, the idea is that annotators should write out this ROU, record of understanding, which is a semi-structured document containing all of their idea of what the important spatial content and temporal content is, like where Rover and Allie are at different points in the story, what events happen and when, as well as all of that motivational and causal information. This is an example specifically of a motivational explanation. So answers to these why questions that will get pretty detailed, right? Really digging into all of the reasons why Rover decided to run inside rather than staying where he was, and trying to explain all of the pieces that go into that thinking, to that agentive move, and how they relate to each other. And we'll talk about the details here more in a second. And then once you have those documents, we want to turn those documents into really rigorous tests where we can evaluate either systems free text output or evaluate systems on multiple choice questions based on that content. And really what we're trying to do when we get annotators to create documents like this is to have them commit their mental model of what is happening in the text, in the story, down on paper. This is a pretty different kind of annotation from linguistic annotation. We're not directly tying these annotations to words and phrases in the text. We're trying to get them to articulate a set of concepts and ideas and pictures in their head. Obviously, we can't get everything that's in their head, the entire mental model, but this is supposed to be a floor for comprehension, a minimum, that this is necessary material. If you don't understand this stuff, then you don't understand the story, and we shouldn't trust you to understand future things that you read and to claim that you can really do reading comprehension writ large. Now, I want to dive into the details here a little bit more about what an ROU looks like and how we help annotators produce them, just largely to show you how thorough we're trying to be, and also, again, some of the interesting problems that came up and ways that we approached resolving them. So recall that these are the 4 clusters of questions that we're looking at: spatial, temporal, causal, motivational. It won't be surprising, I think, that causal and motivational questions are difficult to work out how to answer in a rigorous and consistent way. But actually, even spatial and temporal questions can be pretty tricky, and sometimes in ways that are more subtle than you might expect. Here's another example story that I'll use to dig into the spatial and temporal stuff. So when Bobby went hiking, mornings were cold, mornings often got hot. What should he wear? Bobby put on a t-shirt, a sweatshirt, and a jacket. During his hike, Bobby felt warm. He took off his jacket, tied it around his waist. Later, he took off his sweatshirt. The t-shirt was nice and light. So this is a pedagogical story for young kids, for like first graders. A little bit more complete than the example we saw before. Some of these spatial and temporal issues here are standard stuff that are addressed pretty extensively in the NLP literature. This is things like recurring events. Bobby goes hiking often, apparently. There are long-lasting events that span many other events. His hike lasts all day, including all the taking on clothing and putting it off, taking it off later, whatever. But there are also some somewhat harder issues that come up that I think maybe don't get quite as much attention as they deserve. Things like continuous processes. Getting hot is actually not a discrete event. It's certainly not something that happens at one moment in time, but it's not even really something with a well-defined start and end time. This is just a thing that's continuously happening from some time in the morning, late morning, to some time in the late afternoon. So we have to account for that fuzziness. There are also things that arise because we're not just annotating text directly. We're really trying to capture all the things that a reader imagines or sees happening based on the story. So here's what should he wear is this is Bobby wondering probably what should he wear. The word wonder doesn't appear anywhere. This is the narrator speaking as Bobby. There isn't really exactly text to annotate as the wondering event, but we do want to capture that. So there are things that are implicit or semi-explicit that we want to capture. And there are really important questions about granularity. Given that we're not bound by the language that the text chose to use, if we're talking about Bobby putting on all these articles of clothing, should we start talking about Bobby's body, Bobby's torso, Bobby's shoulders and back, just Bobby as a whole? Well, what about the fact that later on he's actually doing something with his waist? His waist plays a role. So there are important granularity things that get really hard to decide where you have to be, how granular. And similarly for time points, for describing the temporal relations, later he took off his sweatshirt. This one is not only vague, but also, you could imagine describing a series of events at a higher level or at a narrower level. You break up events into smaller pieces, you break up time points into smaller pieces. So these are all questions that we're going to have to deal with. To help annotators cope with all of that, we've developed a multi-step process that seems to help quite a bit. The first step here is pre-listing what we call story truths. This includes listing story-relevant entities, locations, events, and a bunch of types of relationships and types that don't change throughout the story. What this looks like in text form in the ROU document is something like this. On the left side, there are lists of entities and locations, and these we actually don't expect to test systems on. They're not the essential pieces of information. What they are is an inventory that annotators can then use to help them work through and make explicit all of the pieces of the spatial and the temporal and the causal and motivational stuff downstream. On the right side, the static identities and relationships, that is actually stuff that we want to test the system on. We want to find out, does it know that Bobby owns the t-shirt? And really, this is in a sense an event. It's just an event that you would keep having to say, like, Bobby owns the t-shirt throughout the story. Bobby owns the sweatshirt. And that just feels weird to annotators because it's static. So we put that in its own section. Things that occur are again going to be an inventory for annotators later to talk about temporal relations and causes and motivation to help them understand what things they need to explain and describe. They also actually are things you want to evaluate on, though, because this is where we get the inventory of things that a system would think happened. So we want to make sure that it knows what things happened and what things didn't. Once they have those inventories, annotators can then proceed to trying to articulate the spatial relations. And for this, we found that it's very helpful for annotators to do what we call blob drawings. They do both at a macro scale for the entire story, what's the map of the world of the story, and also for individual scenes in the story. So it looks something like this. Is a very different story from the ones we've been describing, but should give you the flavor. They sketch out the kind of where all the fixed pieces are, and their locations relative to each other, distances, sizes, part whole, all that stuff, and then do a similar thing for individual scenes step by step as the story proceeds, showing where all the pieces are, the entities are at different moments in the story. And so then when they read those drawings off into English statements that look something like this, both the static and the time-bound statements. Very similar thing for temporal relations. We have them sketch a rough timeline that has all those things that occur that they inventoried earlier, place them on a timeline, try to describe their start points and end points if they can, annotations for add annotations for ambiguity or for distances, like time gaps between things, including durations of events, which is just the distance between its start and end. Put all that on a rough timeline and then read those statements off as, read those relations off as English statements. So as an example, here we have a recurring event described, the hiking episodes before the main episode in the Bobby story. We also have description about how often those hiking episodes occur. And then we have a full accounting of all the individual events in that main episode, when each one occurs relative to the other, you know, how long before it, just kind of stepping through the timeline. And we have pretty thorough guidelines about how to take that drawing and translate it into text like this. Now, all that was just the warm-up, because causes and motivations, where it really gets fun. Here is an artist's rendering of me trying to figure out causes and motivations. I won't subject you to the blow-by-blow account of all the problems we encountered and the false starts we had. We can talk about, again, in the Q&A, we can talk about what makes this so challenging if people are interested. But suffice it to say, this is very hard. These are questions people have been debating for millennia. And so on this front, we made a novel move. We consulted people outside computer science. There are some really useful insights from the social sciences and philosophy about what we really want here. What we're going for is the answers to why questions, explanations. What makes a good explanation? Well, that's whatever makes a good explanation is what our answers to these questions should look like. So there's this excellent paper from Tim Miller, Explanation in Artificial Intelligence, Insights from the Social Sciences. If you haven't encountered this paper and you're doing anything that involves any notion of explanation, I can't recommend this paper strongly enough. It is fantastic. It gives a really nice layout of what people think about explanations. And the #1 takeaway from this paper is that explanations are contrastive. They are sought in response to particular counterfactual cases. People do not ask why event P happened, but rather why event P happened instead of some other event Q. So that's going to be the foundation on which we're building our are causal and motivational explanations. And this is also supported by a good amount of literature in philosophy. There's some, again, this is a topic that's hotly debated in philosophy, what cause and effect and what explanations really are about. But some of the most compelling modern accounts argue that causality is not really a two-place relation. Really, it's a four-place relation where we have the cause and some alternative to the cause. And that leads to the effect, the cause happening rather than its alternative leads to the effect happening rather than some alternative to that effect. So armed with this knowledge of how we can think about causality and explanation, we can return to this question of what an answer to causal and motivational questions should look like. We're going to conceptualize this explanation as looking at two contrasting worlds and tracing through in lockstep how those two worlds would evolve. In the case of an agentive explanation, motivational explanation, we would be looking at how the agent imagines things unfolding given their action rather than some alternative to it. Call that the realized world versus the alternative world. In a case of a more mechanistic explanation, we'd be looking at how previous events happening as they did in the realized world led to this outcome rather than the events in the alternative world. Let's look at an example. Returning to our rover in the rain example, the thing we're trying to explain here is rover runs inside. What was the alternative to that? Well, he could have stayed put. That is the most natural counterfactual here. At least it is a very natural counterfactual here. What does rover think that running inside will buy him? Well, if he runs inside, he'll be inside rather than being outside, which he would be if he stayed there. If he's inside, he won't get rained on, at least not anymore. And if he's outside, he will keep getting rained on. And he'd rather be not getting rained on than getting rained on. So he'll be happier with the end outcome in the running in case than in the natural alternative. This is, we would argue, what an explanation for why rover runs inside should look like. We call this a contrastive causal chain. And the contrast here really is actually very important. Look at that last link, for example. Rover will be more satisfied, rover will be less satisfied. You can't even really talk about that in absolute terms. There are no absolute values of satisfaction happening here. This is really about preferring one option to the other option. It's intrinsically contrastive. Also worth keeping in mind that in this case, these last three steps are not things that actually happen in the story. They're things that rover is imagining, or maybe they happen in the story, but they're things that rover is imagining when he takes the action are going to happen to him if he takes this action. That's because this is a motivational explanation. So these events are taking place in planned space inside his mental simulation. In contrast, there are also mechanistic explanations. This is that those causal questions. And I'm overloading the word causal a little bit, apologies for that. But in addition to the motivational questions, we have mechanistic explanations where we might be explaining something like the plant turns green. That's perhaps, we have a story about a plant that was on the floor and got moved to a window and then went from being unhealthy and brown to being green. So how would we explain that? Well, the plant turns green is now the outcome that we're trying to explain, and we would trace backwards in time to say, why did it turn green rather than remaining brown? Well, because it was now healthy rather than being unhealthy. Why was that? Because it got more light rather than getting less light. And the reason that happened is because it used to be in the window, it's now in the window and it used to be on the floor. I mean, we stop when we get back to something which, from the perspective of the story, just happens. It just doesn't seem to have a clear cause that anyone in the story cares about. You can think of these explanations, the mechanistic explanation is kind of tracing backwards until the causal chain disappears back into the mists of time. And the motivational explanation here is an agent tracing their simulated version of the world forward until it disappears into the uncertainty of the future, or until it gets to a point where they know or have confidence that they'll be happier or less happy. By the way, I just want to note that what makes something a motivational explanation is not necessarily that it involves an agent. You can have mechanistic explanations about agents. If, for example, you're talking about agents as being mechanistically influenced by their emotions and by their upbringing and so forth. What distinguishes a motivational explanation here is this element of planfulness, that they're looking toward the future, trying to achieve certain outcomes that they prefer. With all of that in mind, we can now talk about how we actually construct these causal chains in an ROU. This is what we're training annotators to do for causal and motivational questions. We train them to identify that salient contrast that might have led to a different outcome, construct that causal chain, and then explain all the pieces of the causal chain recursively if necessary. What does that look like? Rover runs back inside rather than remaining outside. That's that contrasting alternative to the thing we're explaining. Rover would prefer not getting wetter to getting wetter. That's how we characterize that final outcome, that difference in preferences and in being satisfied that we saw at the end of that previous example causal chain. And now everything beyond this point takes place in Rover's mind. So Rover believes that all of this sequence of contrasting statements. He will get wetter if he gets rained on, whereas he won't get wetter if he doesn't get rained on. But we don't want to just stop there. That's just an explanation of of events within this world that might affect Rover's behavior. We also want to appeal to general causal rules about the world that explain why things happen. These are a key part of the way that humans explain and answer why questions. So it's not enough really to say that he will get wetter if he gets rained on. We want to know why he will get wetter if it gets rained on. Well, that's because there's this general pattern in the world where when rain falls on something, it gets wet. And if it doesn't get rained on, it stays only as wet as it was before. In some cases, even that general rule might not be enough. Here's an example where we need to say, not just when it's raining outside, things that are outside get rained on. We also need to establish that it is in fact raining outside. So that we add those supporting facts into the explanation as well. And so on down the rest of the causal chain. And we build causal chains like this for every event in the story or every important state, everything that happens in the story. Sometimes there will even be multiple contrasts for a single event if multiple contrasts seem salient. Phew, okay, we have ROUs now. Great. Obviously, with so much going on in an ROU, we can't expect annotators to always agree on all this material. Fortunately, this is a lot like summarization, which is pretty well studied. It's a case where there are lots of potentially valid answers to the questions that we want systems to produce, but some of those answers are clearly better answers than others. So we can borrow a technique from summarization evaluation called the pyramid method. Rough idea here is we divide ROUs, divide the content we're evaluating on into nuggets. So we might have a nugget, for example, that says that part of why Bobby is putting on the t-shirt is that it's a light article of clothing. And different ROUs will include different nuggets in their explanations or in their descriptions of the temporal relationships and so forth. And we can weight in the evaluation, we can weight nuggets that get included in more annotators' ROUs more strongly. So if we have 4 different ROUs that all include those 2 nuggets on the top, those are each worth 4 points. But there are some among our 4 ROUs, let's say, that only get included in one or the other. And so the ROU that includes more of the 3-point nuggets will get more credit than the one that only includes 2 of the 3-point nuggets. But those are still less important than the 4-point nuggets. There are still some nuances that we'd have to work out here to apply this in a complete way to our scenario. In particular, our ROUs are somewhat structured. It's not just a collection of nuggets, really. And so we probably need to have some alternative scoring methods based on this, where sometimes in one version of the scoring, you could just get credit for stating that, for example, someone wearing heavier clothing feels hotter than someone wearing lighter clothing. That's part of the answer. Another scoring method where you might just get additional points for correctly connecting that fact to how it relates to Bobby expecting he'll be hot if he's wearing heavy clothes while he's hiking. Right, so there are some pieces here that are still unresolved, some details to work out. But we do think that this is a doable and promising approach to handling the disagreements between annotators. In fact, we're not even really thinking of them as disagreements. We're thinking of them as providing complementary information about what somebody in the world thinks is an important, essential fact to understand from this story. Now, even with the pyramid method, we don't end up completely necessarily with an evaluation data set. We have a bunch of documents now, right? We have a bunch of semi-structured documents with all this dumped information from the mental models of annotators. That's not quite an evaluation. So how do we actually evaluate systems on all this content? Simple method is compose some multiple choice questions. So we might compose questions targeting each nugget, like where is the t-shirt, right? Where is this item at this point in the story? We can target temporal questions by asking about ordering. We can ask about what events or what states hold at the same time in the story. We can also target those causal chains by asking both questions like, what does Bobby believe will happen if the jacket is not attached to his waist? Asking about what are the alternative scenarios that are in play here? And also asking for the recursive explanations, the connections even between the links and between the causal links and the recursive explanations, things like what general pattern is in play about Bobby attaching his jacket to his waist. Really trying to drill into as much as possible of the details captured in that ROU. There is also some additional work here that we haven't yet explored, but I think would be interesting to explore, called STARC. This is Structured Annotations for Reading Comprehension, which provides, this is a paper from 2020 that provides some interesting methodologies for systematically generating the distractors for these multiple choice questions in a way that provides some meaningful insight into where the system, it helps with error analysis, basically. It helps distinguish some ways in which the system might be failing. Now, as I said before, in the longer term, we're not really super satisfied with multiple choice as a testing paradigm. We think that systems really should be ultimately evaluated on free-form answers. Unfortunately, this is the part where I have to start waving my hands a lot and saying the words work in progress. We don't have really complete answers to how this could be done yet. We do have some ideas that we've started experimenting with. You could just, human evaluation is a strong possibility here. I know that it's not super typical in NLP to do human evaluation. It's expensive and inconvenient, but I think it's worth keeping in mind that in many different kinds of NLP tasks, the community started with human evaluation and then later discovered automated metrics that correlated reasonably well with human evaluation, and those can be used for development and iteration. And so at least as a starting point, and really I think ultimately as the final rubber stamp of approval, but at least as a starting point, human evaluation seems fine. We can probably get systems to output things in an ROU-like format. And so we can have a human just compare head to head and say, I have my rubric of all the nuggets that the pyramid method helped us put together and all the weights on those different nuggets. I'll just score this ROU-like output and see how much of the right nuggets does it get and how many of the how many erroneous things does it say. So that seems potentially doable. Probably it would be easier though to have humans ask more targeted, narrow questions like when did this event happen? When did this happen relative to other events? And perhaps even drill down from bigger picture questions into these more granular questions, like start with what events happened, see if it can tell you a list of events, but don't expect it to put everything ROU style all at once. And then once it gives you its list of events, it can start, you can start drilling in to say, when do you think this happened? How long was it between these events and so forth? That would also mitigate some concerns about the questions the human asks, revealing too much information about things that we really want the system to be able to produce or demonstrate comprehension of on its own. Now, human evaluation is expensive. So at least for development and training, we should be able to find some automated metrics that correlate well or approximate human evaluation. How that would probably work is we would have these somewhat more targeted questions like, why did this event happen? The system would output, it happened because blah, 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 give some ROU style chunk, right? Like an entry in a single entry from an ROU. We then try to align the pieces of that output with the pieces of the ROU content and score them for precision and recall and that sort of thing. How exactly you do that scoring is kind of tricky. We've tried experimenting with BERT score for this. We're not terribly impressed with the results. At least for our intuitions, it did not correlate well with our intuitions as humans in terms of how close the outputs were to the information content from the original ROU. There is another interesting direction here that we'd like to explore more. A recent paper with this evaluation metric called MOCA, which is a trained evaluation metric. It's trained specifically for question answering, fine-tuned for that purpose using question answering data sets. So that seems like a promising direction. We have not yet investigated it, but it may produce some nice results. All that is evaluation approach 1 based on ROUs. I'm not going to say much about the second evaluation approach here. Just to briefly run through it, there's another possibility. ROUs mean that you have to specify what you think an ideal output of a system should look like. We may want to avoid that. We may think that this is too open-ended and we just can't get good enough annotator agreement here, in which case you can have a human judge simply ask a question to a bunch of systems, let them output their answers and rank them. And whoever gets ranked best by the human judges wins the competition. It doesn't give you quite as much of a sense of how close are we to broad machine reading comprehension as a big target, which is one of the reasons I find it personally a little less satisfying than the ROU approach. But especially if you sort of try to guide the judges in terms of dimensions that they should be considering in their evaluation, that will hopefully or could potentially provide some useful information about what systems are doing well and which are doing not so well. Great, I have just dumped a lot of information on you. Let me pause for a second there and see if there are any questions, thoughts, comments. Not too much coming next, so we have some time to deal with questions now if people want.
I have a question.
Sure.
How many ROUs have you collected?
I'm getting to that in the next section.
Okay, good. Anyone else? Okay, let's go on.
Okay, let's go on then. That's the overall research program, the kind of paradigm we're looking for. We don't just want to propose it, we do want to pursue it actively ourselves, including things like producing those ROUs, as Laurie just pointed out. And we have made some progress on building out these data sets and testing existing systems on ToU-based questions or ROU-based questions to get more specific, I guess. The first thing we did was we tried to test some existing reading comprehension systems based on questions using an approach like this. We started with a data set, the RACE data set, which is one of the most popular, I think, reading comprehension evaluation data sets. Like our TOU, it is focused on stories, which is convenient for us. So we had an annotator look at 2 of those stories and write out 2 full ROUs. Now, these are actually not, I would say, the most high quality ROUs we've developed. They were made a little earlier in the process. We didn't have all the guidelines in place. So probably we could make these even more thorough and more rigorous. But this was a starting point. Drop some ROUs for these stories and then generate around 200 race-style multiple choice questions covering all of those statements in the ROUs as thoroughly as possible. Now, if you look closely at these 2 examples here, these are actually basically the same question. And the reason for that's very deliberate. The reason for that is that, maybe it takes a little more context from the story to recognize that these are exactly the same question. But trust me on this if it's not obvious. They are the same question. They're asking about the same outcome in the story. The reason we did it that way is we wanted to mitigate some of the artificial easiness of multiple choice, where the patterns and the wording and the distractors can offer cues that models won't be able to generalize adequately. And so to kind of prevent that, we created groups of questions about the same content, which we called variant groups, where we ask one question and then ask a very similar question that targets the same thing from the ROU, but in a differently phrased question with different distractors. And the theory here is that this gives us a stricter scoring option where we can evaluate both questions as a whole, but also we can say, look, I'm going to simulate a human judge who can be skeptical of an answer here. I suspect that you might have gotten that first one in the variant group right for the wrong reasons. So now I'm going to ask you the same question again and see if you still get it right. And that lets me evaluate more strictly whether you're actually able to answer these questions reliably. So we can do an all or nothing evaluation on each of these variant groups. The results from this experiment were not terribly impressive, I would say. We used ExcelNet, which was the large language model that was it was more or less state of the art when we ran these experiments. State of the art on race, that is, best performance on race. And even within the guardrails of multiple choice, with all its flaws that we've discussed, we were seeing humans getting 95% on these questions. And I think, frankly, even those one or two questions humans weren't getting were, like unclear questions that we should have just phrased differently. ExcelNet was well above chance, but it was really quite a lot lower than the humans. Not too much of a difference, actually, between the spatial, temporal, and causal and motivational questions there. That suggests, so the big kicker here is that the accuracy when we went to variant groups was significantly lower. Humans have no problem with this. Humans do exactly as well on variant groups as they do on individual questions. But ExcelNet really starts to suffer if you make it answer a very similar question that's phrased in a different way. So that strongly suggests, and it's a small experiment, it's not, I wouldn't say this is proof positive, but it strongly suggests that systems like ExcelNet are really going to struggle to answer questions based on this kind of content in a robust way, right? It suggests that the multiple choice is artificially easy for the systems, and also that there is a lot of room to, plenty of research work to do here to make models that can perform well on the ToU. Now, to get to some of the work we're doing on actually expanding this, and some of the things Lori was asking about a moment ago, we have been working, this was a pilot experiment, we've been working toward a much larger corpus, much larger evaluation challenge. And we have, to that end, we have this extensive annotation guideline with lots of examples and battle-tested processes and special cases and all that. We've used that to annotate about 10 stories with complete ROUs, each annotated by at least 2 annotators. We also have about 8 additional stories, depending on how you count, where we have either a single annotator ROU or a bunch of annotators who've annotated part of the ROU. We have, I'd have to check the exact number. I don't recall it offhand, but I believe it's on the order of somewhere between 100 and 500 stories that we think we can get pretty good ROUs for, that we have in the bank already. As far as the actual annotators doing this work, we have 8 fully trained annotators, some internal, some external, recruited from pre-existing Mechanical Turk relationships, and 7 additional annotators in training working their way through this training sequence that we've built up of sample stories and sample ROU subsections or small chunks of ROUs that they're being asked to produce that build up in complexity to make sure that they internalize the guidelines, core guidelines, before then getting onto all of the special cases. So this is still relatively small, but we're making progress toward a moderately sized data set. I don't think this is going to be a data set that's big enough for training a neural model on and expecting really good performance. But maybe that's actually a good thing. Actually, there have been a lot of discussions recently about evaluation-only data sets being a promising way to test whether systems can really robustly generalize from things they've seen. So an evaluation-only data set would be very much in line with our general goals of measuring how close we are on reading comprehension writ large. Anecdotally, agreement between annotators is pretty good, but we do still need some more work to assess it rigorously because this is still evaluated on a fairly ad hoc, informal basis. Generally, they agree on most of the spatial facts to include, what events to include. Interestingly, they do choose very similar counterfactual contrasts for the events that they're explaining. So that was encouraging to see. They also theoretically could keep explaining facts recursively further and further and further until they bottom out in one of those general rules, but they seem to choose to bottom out at about the same place. So it's promising that there's some conceptual consistency here to the way that they seem to be approaching giving explanations. There are still some important sources of disagreement, such as which implicit events to include, where to split the causal chains into different links. That could be things like, do you say, I dropped my glass, therefore it shattered, and do that as 2 steps, or do you insert extra steps, like I dropped my glass, so it fell, so it shattered. That sort of thing is sometimes inconsistent, or exactly how they choose to structure the bullets. They do also sometimes forget facts and rules that seem self-evident, and sometimes do choose different choices of causal contrasts to explain against. So this seems like, again, promising. We've gotten some really good improvement in all of these ways, all these dimensions, by robustifying our annotation guidelines and training and practice. Again, we probably will need to resort to pyramid style changes to make sure that we can really incorporate all these different perspectives from different annotators. Let me just close quickly with a few words on where we see all this going. We really do want to produce a rigorous challenge data set from this work. There are 2 big lines of work remaining to make that happen. The first is developing the data, so finalizing those guidelines, getting better quantitative measures of inter-annotator agreement. That probably means we need to make sure that the guidelines, so the pyramid method comes with guidelines for extracting nuggets for summarization, but we need to adapt that methodology to this context to make sure that we have a clear and well-defined notion of what a nugget is and how you should be aligning nuggets between different annotators' ROUs. We need to finish training up those annotators in the pipeline and let them loose on all of those stories we have waiting in the wings. And then in parallel to that, we also need to make sure that we have good processes for transforming those RU documents into the evaluation data set, whether that's by multiple choice or just using the free text. Defining the free text evaluation setting more precisely, that means figuring out exactly what questions get asked as prompts for free text answers. Do you start with those really general questions? Do you have the evaluators drill in and so forth? And also, as I mentioned earlier, finding automated metrics such as MoCA that can approximate human judgment. So this is just to summarize all of those pieces that I hinted at earlier that are still remaining. Those are the things that are remaining in the short term. We do really see this ToU idea as a potentially powerful research direction in reading comprehension research more broadly. So to that end, the points that I want to leave you with are that we argue that reading comprehension tests should be grounded in the content applications need, not just in what seems hard. That they should be constructed from the passage directly and in this principled, systematic, rigorous way. They should be comprehensive, including all those obvious questions that humans don't think of. And we've tried to demonstrate some methods for doing this and work towards some methods for doing this using our annotation approach for transforming stories into ROUs. I also want to point out that we had to dive into some pretty knotty philosophical issues here to figure out what the right answers were. And I think if we really want to be doing good work in NLP, sometimes we have to not shy away from that, not just try to let somebody else feed us the objective function, but really dig into what do the right answers look like, even if that means thinking about questions that feel not very computer science-y, because there's a lot of really good insight, particularly from the humanities and social sciences, that we can learn from there. We're not going it alone, and it's not necessarily terrifying to talk about even something as conceptually difficult as causality. And then, of course, this is just the start. We don't have all the answers here, but we think there's plenty more work to get these evaluations in shape, evaluations and building the corpus. But then beyond that, this is supposed to be the basis for a whole world of ToU-based reading comprehension research. So let's build the systems that can actually pass these tests, that can do well on these tests. that means bringing in all that work that I said at the beginning I won't be talking about on what kinds of data do systems need, what are the modeling techniques that we need, and perhaps even expanding that beyond stories to other domains, other kinds of applications. Really taking this TOU idea and running with it to see what kinds of reading comprehension systems and tools we can come up with and how they can be most useful. So we would be excited at Elemental Cognition to collaborate with any of you on this stuff. We welcome any ideas for that kind of collaboration, whether that's sharing ideas or joint projects or consulting. Some of you may even be interested in joining the EC team. So please feel free to visit our website to learn more, email me directly, contact me by other means if you find them. And I hope that we can really make some progress on deeper, more compelling reading comprehension evaluations and systems.